formation of enamines. Aldehydes and ketones, when they react with secondary amines, they will form enamines. Enamines are alpha, beta, unsaturated tertiary amines. So you can see that there is unsaturation at the alpha and the beta position. So this carbon right here is alpha, this is beta, and you can see that there is a double bond between these two carbons. And this nitrogen right here is tertiary because it is attached to 3 carbons. So enamines are alpha, beta, unsaturated tertiary amines. Now, why this compound is called as an enamine? Because we have a double bond. For double bond, we generally use the term "ene", right? And you also have an amine. And therefore, both put together, ene plus amine equals enamine. Just like the imine formation, the enamine formation also needs trace amount of acid. Let's take a look into the mechanism. First, to begin with, the amine is going to make a nucleophilic attack on the carbon or the aldehyde or ketone. So here it goes and attacks this carbon, thrusts these electrons onto oxygen. This is going to form as an alkoxide ion, like what we have formed in the case of imine. And once this alkoxide ion is formed, it's going to go grab a proton from the acid that we have added. This is going to result in a protonated intermediate. And in the next step, a base will come and abstract this hydrogen and neutralize this positive charge on nitrogen. And this has resulted in a neutral tetrahedral intermediate, also called as carbonylamine. Now in the next step, the hydroxy group is going to get protonated. Now once this is protonated, it is going to get converted into a good leaving group, right? So the water is going to leave as these electrons come in to form the double bond. Now we have actually formed a protonated imine. So all of these steps right here, from the beginning to here, are exactly the same for imine and enamine formation. The only difference here is in the case of imine formation, we'll be using a primary amine, but here we use a secondary amine. In the imine formation, we did have at least one hydrogen on this nitrogen, but here, since we used a secondary amine, we do not have any hydrogens on this nitrogen. So because of which, one of these hydrogens will be abstracted by a base, and it will push the electrons to form the double bond, and that's going to neutralize the positive charge on this nitrogen. To form the final product, which is in enamine, where you can see that there is a double bond between these two carbons and a single bond between the carbon and nitrogen. So this one right here is an enamine. Enamines can undergo hydrolysis to give us back the original compounds that we started with, original starting materials that we started with, basically the carbonyl compound and the amine. But here, the amine is actually going to be in the protonated form in the presence of acid. Now, because this is in the protonated form, the reverse reaction is not possible because the amine is now protonated and it's no longer available as a nucleophile for it to go and attack the carbonyl carbon.